Hello, good afternoon. How's everybody? All right.
Good, good afternoon.
Good afternoon, Ivan. Ah, everybody is only just, typing into the chat box. How are you, Tiana? Good afternoon, Nicholas. Um, there are, so how many people are here now? Looks like, 13, 14. Let me just, let me just check. Um, Let me check how many people are signed in on the discussion board first, and then let me see. Um, so today is this I'm looking into March 4th. So actually, there are only 12 people in the. This is disappointing. 12 people in the discussion board. Now, I sent out an email. Uh, Email to uh, bring you all to the collaborate uh, this morning because uh, we're gonna have some preview, or let's say not a preview, but probably a question and answer sessions about the homework too, because I've got some emails. I mean, people, when I ask them to say something, they don't say anything, and then they send me an email asking, basically uh, the gist of the email is that they don't understand what to do and how to do uh, homework too. So that's why I brought you all here, because there seems to be uh, there seems to be some uh, uh, lack of understanding, or basically lack of understanding uh, the lecture. So let me go over uh, the assigned. I think the assigned problems. I'll have to look at two documents because first of all, let me download. Let me download the. Do not. Let me download the screenshot of homework two. Uh, but do not rely on the screenshot, because the screenshot is so poorly done, as you may understand. And it wasn't me actually. Some students actually, years ago, some students, just took it by camera, phone camera, and they just posted it onto on the site. So let me just. Let me just copy and paste. All righty, and let me open that. What happened? File not found? What is? Okay, I have it here. So let me share that with you. Uh, share application. All right. So you must be able to see just about now. Do you see it on your screen? You see it on your screen, right? All right. So,
Yes.
yeah,
Yes.
good, good, good. I wonder if there's any way I can blow this up and make it look bigger, but I guess this is the best
Yes.
I can do. Okay, all righty. Thank you for that confirmation. Now, and I don't think I can blow it up anymore, but 12-1, right? 12-1, because 12-1 is the actual homework. 12-1A is the actual homework. I will do 12-1, and the screenshot doesn't include 12-1, so let me open another one. So this is the ebook. I mean, the publishers. Oh, why is it so big? 125 is okay. So let me share this with you. I first have to stop sharing this and do it again. Please bear with me. I believe it is this one. Okay, and about now you must be able to see it. You see it now? So LU 12-1 practice quiz. So this is, solve the example. But, I told you not to follow the book because the book is doing it like a elementary school. It's actually an insult to the intellect of a college level. I mean, it's an intellect to a college level student. Insult to a college level intellect. Doing it, the way they do in the book. Now, so some people were asking, so how do I do this? They are asking, complete the following without a table. Okay, without a table. And then, using compound value table. Look, first of all, you must do it without the table. If you don't use and I also explained last time, the interest factor table has so much, so many limitations. So you can do it exactly. Number two can be done exactly like number one. Now, and then some people are asking, so how do I? Okay, how do I, do this? Well, first of all, it says principal. So that's, we can identify the relevant variables. So principal, that's P, time, yeah, T, rate of compound interest. This is APR. What do you think it is? It's APR. Rate is always given as annual, so that's APR. And then number of periods to be compounded. It says quarterly, number of periods to become quarterly. So that means what? That means M is 4. M is 4, right? Now, some people are asking, in the past, when I collect the homeworks, and then I see some students, actually type in the word quarterly. Look, words are not numerical data, and texts are not data. Texts are text. They are not numerical data. And then numerical data cannot be operated on by Excel. I mean, text cannot be. Only numerical data can be operated on by Excel. So you should eliminate all text, okay? All narratives, all verbiage, and principle. I don't type in principle. I always type in P, or at most P, R, and C. Use symbols, because this is something I've noticed also from the last homework. Some people really type in all the words. Why don't you type in the narratives then? Huh? What's it gonna make? What's it gonna make the model look like? This is not a prose. This is not an essay. You don't type in lengthy verbiage in Excel. The model should be very concise, compact, and terse. You understand? The more concise and the more compact the model is, right, the more powerful it is. So this is M, and then, okay, number of periods. I think A is the number of periods to be compounded, number of periods to be compounded. So that's N, the actual number of compounding. So compounded quarterly, this means that's M. M is 4. And total amount, of course, that's the future value, right? Total interest, that's the interest alone, interest per se, right? So to do this problem, I will build, okay, let me.
Question.
Yeah.
The notation for total interest, would that be just the small I?
No. Lower cases, the convention is that the lower cases are either the length of time and interest rates, the rates only, right? The dollar amounts are always in uppercase. Okay? Dollar amounts are always in uppercase.
Okay. So just be like interest and then in parentheses dollars.
Yeah, you can do it like that, but by putting I or INT in uppercase, that means that's already dollar interest.
Okay.
Okay.
Copy.
Rates and the lapse of time or duration of time or length of time is in lowercase, right? But dollar amounts or weights, distance, all these quantities are always in uppercase, right? But rates, length of time are in lowercase. Okay, so well, you can use my, okay, let me use my work as a template because to build this all over again, let me build this all over again, okay? So here, let me share this. Let me share Excel file with you.
I have another question, Professor. So in question 4, it says to find the effective rate. So I did that, and just because I just did it for all 4 values. Would you consider that redundant, or I just kind of put down the formula for all other 4?
I don't know. I don't know what question 4 is. Does question 4 of homework 2?
Of 12-1.
12-1. Okay, let me get to that. Okay, I haven't read it, so let me get to that. So let me first share Excel file.
I'm just asking because a big thing for me in homework 1 was redundancy.
I mean, if it wasn't asking for, in homework 1, the first problem, I mean, you didn't get any, you didn't get penalized for redundant, answers. It's just redundant, and it doesn't look professional when there is redundancy, right? It's like you don't repeat and, right?
Right. Yes.
There's a reason why you use Oxford comma, because if you keep on saying and in a spoken language, sometimes it's in a spoken language because you're not speaking as exactly planned, right? So that's inevitable. But at least in written language, it has to be concise and terse, right? That's why you don't repeat and. You don't repeat the same words over and over in a written language. But what is that? What is the idea behind it? The rationale behind it is all the parsimony principle, parsimony, right? You don't want redundancies. Okay, so here, do you see, I hope you can see, yeah, you see Excel, blank Excel file. So what I'm going to do is, first of all, I've shown you this. If you click on this, it highlights the entire spreadsheet. Then from here, I can set the font. I will set it to 14, Georgia or Times New Roman, but my personal preference is this one. But, you know, that looks more. So here I will put, you know, principal or PB, right? PV, because it's, you know, present value and principal, they are the same thing, right? And I will bold and underline and center line, because it's important. Because if you don't center line, if you don't pay attention to this, sometimes it becomes very confusing, because it is aligned with the wrong data, or it looks like it is aligned with, you know, wrong data set. So center line, and I'm gonna drag it across just to maintain the format, right? Just to keep the format going. And then so next is APR. Normally, you know, rate will have to be in lowercase, but because APR is normally, you know, if you go to the bank, they declare APR and APY, and it's usually written in uppercase. They're fine. And time, T, I don't use uppercase for, uppercase is only for what? Terminal time, right? Uppercase is reserved for terminal time only. In other words, you know, end of the, and then M and R N and future value. And if it is asking for effective interest rate, R star. Now, let's go to the setup of the problem. It says principal is 200.
I think it also asks for total interest.
Oh, interest, right? Okay, that's fine. I will move that there. I'll change that. Okay, all righty. So this is like, you know, part ABC. So N is, okay. So this is part A. This is part B. This is part C. Part C, it's always comes up. Okay.
Professor, R star is the same thing as APY?
No, yeah, R star is the same thing as APY. And in this problem, it's not asking for, I just put it there just in case, but this problem isn't asking for effective rate, right? So I make this, you know, I use, you know, $sign for that. And 0.08, 8% is the APR. There you go. And always use 2 decimal places, 2 to 3 decimal places by default, right? And it was 1 year here, and compounded is at quarterly, right? Then M is 4, right? And then what is R? Then R will be this divided by this, right? And then I turn it into a percentage, oops, percentage, and give it 2 decimal places, dot, dot. And N is actual number of compounding, right? Which is now T times M. So 4. Now these 3 are solution cells. So I'm gonna highlight them with bright yellow. I mean, also in highlights, there is a convention. Always the primary solution cells are yellow because it's the brightest color. It easily catches the eye. And for secondary solution cells, it's something like olive brown or drab, or drab, whatever you call it. So I'm gonna then future value is this times 1 plus R times N. Oh, no, what am I doing? 1 plus R raised to N. Okay? And then interest is obvious. Interest is the difference between the two. Right? There you go. Now, this is how you do 12 dash. Okay, so let me. This is LU 12 dash, right? So, and normally I prefer to put the problem number in the far left column, right? So that way, and if necessary, then here I can put part 1, like number 1. This is number 1 in that problem, right? In that problem group. And then if there are 4 problems, you can just drag it down, and I have already. And then what is number 2? Solve the previous problem by using the compound table value. I told you not to use compound the interest factor table, because interest factor table is the thing of the 19th century or early 20th century. So for number 2, I would simply just drag it down. And when you drag it down, it adds $1. So get rid of that. Everything is adding 1 there. So number 3 now. Number 3, Lionel Rogers deposits, and the name really doesn't matter. Some people very kindly even type in those names, though the verbiage is totally useless, right? Lionel Rogers deposits $6,000 in Victory Bank. Name of the bank doesn't really matter, which pays 3% interest. What's important is, what is the P? Right? Identify the variables. What is the P? What is the APR? What is the M? Right? What is the T? Okay, so here everything is, in this problem. I don't know if you can see 12-1. You'll have to look at your book. So in this problem, it says 6,000. So I'm gonna just drag it down just to use the recycle the formatting. Interest rate was, see how easy it becomes, 3%, by having a standardized format, right? You don't have to solve everything all over again. some people in homework 1, some people, especially when it came to problem group, problem 11 dash something, then they were doing it all one by one, explaining, this is, maturity value, and then how you calculated it. I don't need to see how you calculated it. It must be correct if you put in the correct formula, right? So M is in this problem, but in this problem, M is 2, because it said semi-annual, right? So yeah, compounded semi-annually, how much will Lionel have in his account at the end of 8 years? So this is, you already have the answer. And in problem 3, they didn't ask for interest, so it's redundant. I mean, it doesn't hurt. It doesn't hurt. It doesn't hurt to have it there. I mean, especially if you have it there, then there's uniformity in consistent uniformity in the model, in the structure, right? But I wouldn't, because it wasn't asked. It doesn't hurt. It's harmless. But because the problem only asked for what's going to be the future value, right? And then what's number 4? Number 4 there's even number 5. Find the effective. Now we have effective rate. Find the effective rate for the year. Principal 7,000 compounded quarter. Okay, so I will move it here, and then just drag it down just to have, so that I can save time on typing in all and reformatting everything, right? Now 7,000, and then what was the interest rate? APR was 12% and compounded quarterly. 12% and compounded quarterly. 12%. And because this is only what? Compounded quarterly, right? This is only what? Effective rate problem, right? There's no harm in filling out these cells, but this is not the solution cell. I mean, that way you don't have to confuse me, right? This is the solution cell. So I will highlight that. And effective rate, or APY. Okay, the same thing. So what is the formula for that? It's 1 plus R, it's APR divided by M, but that we have that already. It's this, right? And raised to M. Minus 1, something I forgot to do. Minus 1. Okay. And don't leave it like that. Must give it percentage, and don't leave it like that. Don't let it round, because in this case, give it 2 to 3 decimal places by default. In this case, it's rounded up because it's 12.55. But if it was 12.45, if you let it round to an integer, what's it gonna be? If you let it round to an integer, what's it gonna be if it is 12.45? Anyone?
13.
No. If it is 12.45, if you let it round to an integer, what's it gonna be?
12.
12, yeah. And then if you let it round to 12, then there is no difference, right? There's no difference between just visually, there's no difference between APR and APY. That's why you shouldn't let it round to an integer. That's why you should always give it at least 2 to 3 decimal places. Okay?
That's
Alrighty,
what
and
that's what I was asking before, Professor. If I could just put that, like, I just made the APY for all, because I made the formula for question 4, and then I just extended it to the rest. Is that
yeah. As I said, it's harmless. It's harmless.
Okay.
It doesn't really matter. It is harmless, and you don't get penalized for that. But since the question problem part 1 to 3 didn't ask for any APY, it's better not to put APY there
Okay.
because as I said, it's harmless. It just gives me extra chore to look into that,
Yeah.
and I don't
Okay.
have very much time. Let me use my time more efficiently. Please help me use my time most efficiently, and
Sorry,
I
just
would appreciate it. But if you give me extra chores and extra tiredness to my eyes, then I certainly wouldn't appreciate it.
Okay,
Right?
I will not, Professor.
Okay. All righty. And there's part 5 to this problem. Calculate table 12.2 by. So don't use table. And I'm going to tell you why the table is wrong. What 1,500 compounded daily for 5 years will grow to at 7%. So it's as long as you identify the structure of the problem, right? We know what to do. I will just drag this down, just just to have the format, right? And the question was, how much was that? 1,500 daily compounding, 5 years, 7%. So this is 1,500, 7%. Daily, I know it is daily compounding, but what was the number of years?
5 years.
5 years, okay. Thank you, 5 years. And then I'm gonna simply drag it down, just delete this one. See how easily it can be done? Using, all you needed to do was just, first 2 rows. All you needed to do was just these first 2 rows. The rest of them, you can just drag it down, drag it down, drag it down, drag it down, and make some modifications and adjustments, right? And in just 2 minutes, this problem is done. When you get the, hang of it, then in about, 30 seconds, maybe not 30 seconds, but, because you have to read the problems, in 1 minute. 1 minute will be enough.
Professor,
Yeah, I'm listening.
Professor,
Yeah, I'm
I
listening.
have a
Go ahead.
question. So when
Yeah.
it says on question 5, when it says compounded daily, you put for M you put 365.
Yes, it's 365.
Okay. All right.
Well, you might. I'm trying to second guess. I'm trying to guess why you're asking that question, because you remember from simple discount, there's ordinary year and exact interest year, right? So you might wonder, don't we
Yeah.
use 316? No. That's for simple discount. And remember, simple interest and simple discount are used only for short-term time horizon, which means under 1 year. And so they are used basically only for the money market. And compound interest rate is used for long-term capital market. In long-term, meaning, over 1 year, right? With the timeline greater than 1 year. So with daily compounding, it's always 365, right? The exact, exact number of days in a year. Now, let me switch quickly and tell you why. Stop sharing, and then, okay. Where is it? Where is my, yeah. So you should be seeing, do you see this PDF file? You see the PDF file now, right?
Yes.
Yes.
Okay.
Yes.
So this is the interest factor table, and see how limited it is. First of all, number of years, you have up to 30 years only. But think about it. This is what I said last time. You have, every year up to year 10, then jumps to 15, 20, 25, 30. Why? Because this is based on the mortgage market, mortgage, financing situation. Because in mortgage financing, in mortgage, the timeline is the loan term is either 15 years, 20 years, 25 years, 30 years. So the problem is, what if your maturity is 12 years? You cannot use this table, isn't it right? What if your maturity is 72 years? Can you use this table? The table is limited. And what about the interest rates? Like, they should also put the interest rate starting from 1% all the way, but then it's going to be 1%, 2%, only integers. And then from 6%, they have half percent in between. But then look at the inevitable limitations. Beyond 10%, don't they have any? What if the interest rate is 24%? What if the interest rate is 12.725% or 12.725 25? I mean, for those, usually, of course, conventionally, they don't use any more than 3 decimal digits, 3 decimal places. But even then, I mean, for if your interest rate is like 7% and it is you divide it by 3 daily compounding 365, and then how would you find 7% divided by 365? How would you find a rate like that here? There's no way you can do that. But still insisting on using this stupid table is really like an anachronism. It's like, trying to teach 19th century method, because in 19th century, they didn't have a computer. They didn't even have a calculator. They had to do it either by hand, everything by hand. But just to make it easier, they made something for dummy for those days, interest factor table for dummies. I mean, that's basically calculation for dummies. They have prepared this table so that they can just look up. And in accounting classes, they still teach this. And I'm just flabbergasted. I'm just dumbfounded why they do that. Why do they insist on using interest factor table in the age of, it's 21st century. Since 1980s, spreadsheets were available since 1980s. In 1980s, they had Fox Pro, which is the former, like a forefather to Excel. We have computers. Why? And accounting classes still teach this. And if you go to some loan broker office, right? Loan broker, mortgage broker offices, they still have on the wall, they still have this posted, a large poster, like, you know, a large piece of paper, like a periodic table, like the periodic table. They put it on the wall. And like very old, you know, mortgage brokers who have been in practice for like 30, 40 years, you know, um, I, I cannot, don't think, please don't think that I am uh, uh, discriminating, you know, aged people. I'm close to senior. I'm legally, you know, not senior, but, you know, close there. I'm almost there. So, but, you know, I used Excel in late 80, late 80s, you know, mid 80s. I used the Fox Pro. 90s Excel. Never used this table. But if you go to a mortgage broker's, you know, office, they have it like on the wall, like, you know, periodic table, and then they still, you know, use the finger to track the to follow the columns and rows, and then, oh, this is the rate. This is ridiculous. As I said, I'm I'm getting close to a legal, um, uh, still a couple of years away from being a legal senior citizen. But I've never done it. I've always used the computer. I've never done it using the table. But people who are in mortgage business for who have been there in mortgage business 20 years, 30 years, 40 years, they are only about 40 years old, 40 something, 50 something, at most 60 something, and then they still look up the table and oh, this is where they cross, so this is the rate. I just don't understand how they so anachronistic they can be. And anyway, so let me stop. Where is that? Okay, I'll stop sharing that file, and then let me go back to Excel. All right, then what about, let me skip to the next problem. So I believe the next problem is 12-2, because 12-2A is the assigned problem, and then 12-2 is then, let's go to 12-2. I think it's not that difficult. You can I think it stopped there. I don't have let me see if I can. Okay, so please bear with me. I'm trying to find 12-2.
Yeah, it's set up really weird. It's like after the 12-3 diagram in the book. It's kind of out of order.
Oh, all right, but let me. I can download it from the source, right? So let me. Let me do that. All All right, just let me read that to you because I'm already into Excel, right? I'm sharing Excel with you now, right?
Yes.
Is that what you see? Yeah.
Yes.
So let me just
Yeah.
open. Let me open this from. Okay, I think this is a 12-2. Yeah, before actual 12-2 problem, they have these diagrams, right? And then where is 12-2? Okay, practice quiz 12-2. So this is on actually, it's probably making a jump between, the diagram and the. So it says complete this practice quiz to see how you're doing. Use the present value table. It also says it's pretty much, okay. So for 12-2, I'm gonna copy the label and the first row for just for the format, right? Just for the format. So here, and then I'm gonna delete everything. So in 12-2, the solution cell is present value, right? They want the present value. And the problem is, so I've been telling you, don't rely on only the screenshots, because the screenshots may be, skipping some pages, right? And then you need anyway the book, right, to have the full full picture. So future amount desired. Once again, that's future value, right? Don't spell it out. That's really waste of time. The reason we use symbol is to make it very compact. So here, I don't think interest is even asked. So this time, the initial data and the solution are switched. So future value is 7,000, 6 years, 6% semi-annually. Then $7,000, 6 years, 6%. Okay, and all you need to do is, once again, so these are secondary solution cells. So I'm gonna use drab or light olive green, light, and don't use dark. If you use highlight, don't use dark highlights because it's difficult to see, right? It has to be light colors. So it said semi-annually, I believe. I'll go back, check. Yeah, semi-annually. So M is 2, right? And then R would be this divided by this. N would be this, I'm sorry, this times this. And there you go. Then what do you do for, present value? This divide, and this is just simple interest, right? 1 plus R raised to, I had to, I'm sorry, I had to close the parenthesis first. This. What happened? Why is it 1 plus, oh, F12. There you go. There you go. And this is not even asked, so I'm gonna delete that. And I'm gonna, I don't know how many problems, but let's, and then we don't know, but I will just drag it down for the formatting, right? To have the formatting in there. And then the second problem is $15,000 future value. Did I drag this down? Yeah. So 15,000. And then 20 years, 10% annually. So 10%, 20 years annually. Oh, this one is not, I will need to remove the highlight there because that's not the calculated. Then all you need to do is simply, right, drag it down. These things, we'll take care of it later. Then all you need to do is simply dragging it down. And so this way we got the answer, right? And then number 3 and 4, and it's like word problem, right? But then again, it's only a matter of ignore the verbiage. It's a matter of identifying the relevant variables. So Bill Bloom needs $20,000 6 years from today. The name doesn't matter, right? To attend VPR Tech. This doesn't matter. How much must Bill put in the bank today? 12% quarterly to reach his goal. Well, again, then we identify the relevant variables, and he needs $20,000, right? How many years later? 6 years, wasn't it? Yeah, 6 years, and 12% quarterly, right? So 12%, 6 years, M is 4 quarterly. All you need to do is just drag it down, and you got that. And number 4 is pretty much the same thing. Bob Fry wants to buy his grandson a Ford Taurus in 4 years. T is 4. Cost of car will be $24,000. Oh, he knows already what the car will cost in 4 years. Oh, okay. Assuming a bank rate is 8% compounded quarterly, how much must Bob put into the bank today? So it's also asking for the principal, right? In other words, the present value. The price of the car is $24,000, right? And I know it is quarterly. I forgot what the interest rate was. What a nice, grandfather. He's going to buy his grandson a car in how many years? In 4 years, 8%. 4 years, 8%. And all you need to do is simply drag it down. We got that, right? Okay, so this is how you do it. And what you shouldn't do is something like this. what you shouldn't do is something like some people are doing, like, some people are very verbose, like, they they think this is an English composition class or essay class. They write it actually, a and then they type it in, like, they do it like this, and then these things, they don't have any concept, and then they write desired amount. Are you writing an essay? Huh? So desired amount, okay, 24,000. And then they try to calculate, oh, what should be the principal? But then can they use this? This can be used? This 8% cannot be used. I mean, that's because why? Why? Because it's no longer a numerical data. No matter what you do, you can't divide that by, you can't divide anything by a numerical data. You can't divide anything by text. You can't multiply anything by text. You can raise anything to a text, right? You should say goodbye to the childhood where the only thing you knew was how to write and how to do arithmetics on piece of paper with pencil. You should be able to think analytically and systematically in a structure. I mean, for some people who are doing it like this, this semester, maybe, some people in the early days of, online class, some people told me, right in my face, Professor, I don't like the way you're teaching. I watched the video, but I don't learn anything. Look, then whose fault is that? How can they not know how to utilize the video to their advantage? In a face-to-face class, before the pandemic, in an in-person class, my lecture is only transient. In other words, it's fleeting. Once it's gone, once this class is over, it's gone. You cannot rewatch it. So something you didn't understand, you'll have to come to me during my office hour. But with the video, you can play the video over and over until you get a firm grip on it. And then still some people were saying, I don't like the way you teach. And that was not only rude and just impolite, not just disrespectful, but it's just simply showing the lack of intelligence in that person. I mean, you can use the video to your advantage, and that guy wasn't doing anything. In other words, studying, the guy wasn't studying at all, and then only complain. He wasn't making any effort and complaining only. Yes, Tiana.
I have a question. When do you use PMT in the Excel?
Yeah, so that's going to be, I'm going to get to that. That's the annuity problem, right? So your question was how to calculate PMT? Or,
No, actually, when do you use it?
oh, when it is, annuities.
Okay.
If the problem is about annuities. So, I'm sure chapter 13 was also part of the, let me go to the, and also 13, chapter 13 was assigned, wasn't it? Okay, let me go to 13, chapter 13 problem, right? So in chapter 13, what was assigned? 13-1A, so I will do 13-1. Okay, let me go to, let me copy the first row only to just to use the so 13-1, and what's 13-1? Okay, I guess I can show this. This is 13-1. Let me stop sharing this and share. All right, just about now. Do you see this PDF file? Do you?
Yeah, we can see it. Yeah.
Okay, great. Now 13-1, using table 13.1. Okay, don't use table. Any table, as I said, mortgage broker, that, periodic table, like periodic table on the wall of the mortgage broker office. Find the value of an investment after 4 years of an ordinary annuity. It says ordinary annuity already. Of $4,000 made semi-annually at 10%. And B, recalculate assuming an annuity due. Okay, and so I'm going to do, I'm going to have to, again, switch to Excel. And then here, I'm going to have to delete everything. Now, this time it is this one is now initial input data, and this one is the solution cell. Okay, from time to time, let me check. Yeah, okay. And there are 18 people in the collaborate now, so I guess this has a very popular demand. Actually, it's a pressing demand, right? Isn't it? So back here. Okay. Problem again was after 4 years of an ordinary annuity of 4,000 semi-annually 10%, 4 years, right? Let me not forget that. So semi-annually, your M is 2. Every 6 months, you put $4,000 annuity into, you make that deposit. Deposit and payment are basically the same thing, two sides of the same coin. And for how many years did they say? Wasn't it 10 years?
4 years. 4 years.
4 years. 4 years and 10%, right? 4 years and 10%. So and still the same thing. We do, the periodic rate is always APR divided by that M, and N, the actual number of compounding, is always the number of years times M. Okay, and the formula for future value of annuity is what? It's payment times, open parenthesis, open another parenthesis, 1 plus R raised to N minus 1, close parenthesis, over R. Right? Can someone verify and confirm the formula for future value of annuity?
Yes, it's correct.
Huh?
Correct.
Yeah, of course. It's payment times, open parenthesis, 1 plus R raised to N minus 1, right? Close parenthesis. That's in the numerator, and divided by R. Okay, hit enter. We got this. Now, next question was, and this was, ordinary, right? Next question was, do the same problem, but exact annuity, right? So I will drag it down. Get rid of that. Then exact. I will change that to exact. And the what did I say? The difference between the not exact due annuity due, right? Because of that, ordinary year, exact year. What is the difference between ordinary annuity and annuity due? And annuity due has just one more compounding, always, regardless of whether it is future value of annuity or present value of annuity. It doesn't matter. The difference is just one more compounding. So what do? I already have future value of ordinary annuity there, right? And then I only need to recycle this and give it one more compounding. So that times one more compounding, that's what? 1 plus R. Right? Hit enter. Okay? Now, if you want to do it from the scratch, that's fine. Just do it like this, and to this result, right, you put it in a parenthesis and simply give it one more compounding. Right? Well, why do it this way? This is already done here, right? Hit enter, right? Okay. So, and what about then, let's go to number 3. And the number 3, oh, that's it. No, no number 3. And then, then there would be another like 13-2, because now that will be about present value. Now, so here, in the past, a lot of students had hard time doing this before, the remote teaching, before remote, distance learning. This, and the difficulty was they didn't quite figure out whether the problem is about annuity and if or just simple, a single cash flow model or annuity. And even they could make the distinction between single cash flow and multiple cash flow, then they couldn't quite figure out whether it is future value of annuity or present value of annuity. But look, if 13-2, if the given problem, this is the given problem, right? Right? This 13-2A is the assigned problem. And if 13-2 is the assigned problem, then you can refer to 13-2. Because all the problems assigned are like 13-2A, 13-1A. So if you're not sure, you can refer to 13-1 or 13-2 without that A at the end. But again, you must be able to analyze the problem to understand, to be able to correctly identify whether it is, present value of annuity or future value of annuity. You must be able to analyze the problem to correctly comprehend it. Okay, Mamadou, go ahead.
Yeah, Professor, before we
Yeah.
do the calculation for the future value, did we do any calculation to find the value of R and N, or this is a given number? Like the
No, it's not
value
a given number. You
and
have
age.
to do it. Look, I've been showing you. R and N are secondary, it's intermediate calculations.
Mhm.
R and N are not given. That's something you will have to find.
Yeah.
If the problem is like in Word like this, rate 8% compounded quarterly, and please, I'm sure you're, better than the, students in the past who actually typed in this in Word,
Mhm.
and you can tell if it is compounded quarterly, then, R must be this divided by 4, 8%, 2%. So you'll have to put R and N, right? You'll have to calculate that in here, right?
Mhm.
There, there should be M and quarterly, right?
Mhm.
And it doesn't compute. You see why this is causing this problem? Huh?
Mhm.
See, if I do it like that, value. What does that mean? You need numerical data. Excel wants numerical data. Without numerical data, it can't. Why? Because this thing, this is numerical data, right? E18 is numerical data, but C18 is not numerical data. It's text. It's text. It's simply reading text there.
Let's
How
make
can you
this
calculate
assignment more
text?
hard. Is the Excel.
Hmm? What?
The Excel make this problem more hard.
No. Why is
Excel.
it harder?
The Excel only to understand the Excel, how the Excel work, that is another knowledge. You see?
Yeah, but this is just algebra, right? If you can understand the algebra behind this, you can do it. There's no Excel command being used here,
Mm.
right? Is there any Excel command being used here? Is there any Excel command?
No formulas are being used. No.
Yeah, no Excel command. is simply the algebra. So then all it takes is your intellectual ability to identify the algebraic structure of the problem. And then all you need to do is set it up by, you have to first, put in the labels because they are the variables. And the algebra is basically, the combination of variables, right? And then once you set it up like that, you don't have to solve each problem one at a time. You solve only one problem and simply replicate it, drag it down, and you can handle, even if I have like 100 problems like this, I can do it in 2 minutes or even less. I solve only one problem, and as long as all the initial input data are in there, I can just drag it down and problem solved in 2 minutes or even 1 minute. 100 problems, right? How can this be more difficult? And the algebra being used here is not that difficult. It's not high level algebra. It's just, something already taught on like, 8th grade level. Don't tell me you don't understand 8th grade algebra. This is applied math, applied algebra. Basically, identifying the algebraic structure. Even if you do it like the way they show in the book, which is, really, as I told you, the book is like, teaching it like, 8th grade or even 6th grade. Even if you do it like that, still you will have to comprehend the algebraic structure in the problem. You must identify that mechanism, algebraic mechanism. And if you're capable of identifying the algebraic mechanism, then putting it into Excel is, it's a piece of cake. I mean, you just put the labels for the variables and the solution. The only algebra is that is required is the solution cell, right? Small, very little, intermediate calculations here and there. Yes, Tiana, go ahead.
I have another quick question. So present value and present value of annuity is two different things?
Yes, of course. I mean, they are both, present value and future values. But annuity is it's multiple cash flow model. Annuity is multiple cash flow.
Okay.
Just present value is a single cash flow. Didn't you watch the video? Please, watch the videos all over again.
Okay.
Why is it called a single cash flow model? Think of it this. Suppose there's only one, if you put $10,000 today in a bank today, and the interest rate is 10%, compounded just once a year annually, and 5 years later, what's it going to be? The future value, right? This is a single cash flow model. Why? Because there is a cash outflow, one single cash outflow from you today, $10,000 cash outflow from you to the bank, right? That's single cash. And then 5 years later, there will be cash inflow to you. The future value will be coming into you 5 years later. Make sense? So that is, cash one single cash outflow from you, and then one single cash inflow to you 5 years later. But in case of annuity, there are multiple cash outflows from you. If you have an annuity account, so for 5 years, you put into this account every year, like, $2,000 every year into this annuity account. It's obvious it's annuity because you are making a regular payment or regular deposit of regular amount, right? So there are multiple cash outflows from you for the next 5 years. Isn't that right? Does it make sense?
Yeah.
Yeah. So multiple cash outflows. And at the end, right, you receive one cash inflow, which will be the future value of all those annuities. Make sense? So they are, mathematically, they are different, mathematically, right? Now, so that's why they are a single cash flow model and multiple cash flow model. Now, let me go to 13-2 because I think I was, then 13-2 is the present value of annuity. So here, 13-2, what must you invest today to receive an $18,000 annuity for 5 years semi-annually at a 10% annual rate? So are you all looking at this problem, the LU 13-2? And some people, that's why this is why I'm telling you, some people were in the past, not getting it. They don't know why this is, present value of annuity and future value of annuity. They just couldn't. And put some space, enough space, in your homework, because if you don't put any space, of course I can put in the space because it's Excel file, and without the space I cannot comment. There's no space for comment. In the old days, before the online classes, the students submitted the homework in a printout, and when so they had to print out in both normal view and formula view, and then without any space, there's no space for me to comment. There's no way I can correct the work, and it makes my life, difficult on the double. Now, all right, so in this problem, right, it's a future value of annuity problem, and why, people asking why. So this is why you have to analyze the problem. Of course, for a good reading comprehension, you have to analyze. So some people like storybooks, and storybooks seem like always a easy joy read, right? Pleasure reading, or whatever. But look, there are some novels that have very complex structure, and to understand, to follow such a story or movie, or a story that has a very complex structure, you have to read analytically. And some people think if they read, they understand. No, some people just read fast and understand nothing. There's no comprehension. Even in this small problem, there's a structure, and you have to analyze that structure to fully comprehend it. So problem number 1, what must you invest today? So what must you invest today? Then that's asking, what is the present value, right? To receive an $18,000 annuity $18,000. It says annuity. So $18,000 or $18,000 is the annuity for 5 years. Oh, so that means you receive $18,000 every year for the next 5 years. But it says semi-annually. Semi-annually does that means you're receiving $18,000 every 6 months. $18,000 semi-annually for the next 5 years. So there will be 10 payments, annuity payments of $18,000. Make sense? And the APR is 10%, right? So we have we have identified the variables. So payment is 18,000. APR is 10%, I believe. Can someone verify if it is 10%?
Yes.
Okay. And 5 years. Compounding frequency is 2 because it said semi-annually, right? So then we will need to I think this is light enough. I mean, it doesn't have to be that, I mean, but the lighter, the better. So then, we know periodic rate is that. An actual number of compounding is 10 because it's T times M. Okay, so what will be the present value of all these annuities? Present value of 10 $18,000 annuities. So formula is payment over R minus payment over R times 1 plus R raised to N close parenthesis. Everyone okay with this? This is the formula, the variant of the formula that I prefer. The same formula has many variants, but this is the easiest variant, easiest one to memorize. Okay? And also structurally, this makes, this separates, the present value due to the annuities and the present value due to okay, whatever. So hit enter. Yes, this is the present value of ordinary annuities. Okay, so that means to receive $18,000 $18,000 payments every 6 months for the next 5 years, you have to put in this much into the bank today. And also a lot of other problems are related to this. There was a problem about setting up a scholarship fund. Think about it, a scholarship, if the scholarship pays, like this every year or every 6 months, then for the next 5 years, then to set up such a scholarship fund, then you will have to have this much deposited today. And the next problem, I believe, is but do it by ordinary annuity due. No, it didn't ask. Oh, the next problem is actually that one, scholarship fund. But I'm not going to do that because I have already shown you. It's basically the same structure, so you should be able to identify the problems and do it. But let me, since we have, also annuity due, let's, do that. So what did I say? What's the difference between ordinary annuity and annuity due? The only difference is one more compounding. One more compounding. Whether it is future value of annuity or present value of annuity, this one more compounding. And another way of looking at it, I mean, you might wonder, in future value of annuity, if it is one more compounding, in the present value, will it still be compounding? I mean, present value, what is relevant? What is the process that is relevant for present value? It's not compounding, it's discounting. Isn't it right? Discounting and compounding are simply the reciprocal of each other, right? So in this case, and also in the video, I said this. Another way of saying it is one less discounting, right? But one less discounting is the same thing as one more compounding. By doing one more compounding, the exponent in the denominator will lose one. So that will become effectively one less compounding. So one less discounting. So we recycle this result, ordinary annuity, and just give it one more compounding. Okay, and then that's going to be present value of annuity due. Okay, all righty. So I think the time is almost up. We have just 5 more minutes. So class is officially dismissed at 1:40. So with 5 minutes left, is there any question?
Would this be up on Blackboard, the recordings part?
Oh, yeah. Since this session is being recorded, yes, I'm going to put it on
Thank you.
Blackboard. You're welcome. Okay, and there are some questions in the chat. What notation do we use to identify the total interest? Just uppercase I or uppercase INT, right? This is the YouTube page with all the you can. I mentioned this before. I have all the recordings are on YouTube, but not all of them are there because, as I said, some I have different playlists. Basically, they are named all after playlists are all named after the courses that I'm teaching. So there are FMB 100 playlist, FMB 230 playlist, FMB 300 playlist, Business 210 playlist. So some videos are like common to two different courses because they have common ground. So some videos are coming from different playlists. So if you go to the playlist, this playlist, you may not find everything, but at least you can search for by using the right keyword. You can search, and it will come up. Okay. All righty. Any more questions? Okay. If there are no more questions, I will stop recording, and it's 1:38. If there are no more questions, the class is effectively dismissed. Okay. Please, although you didn't watch today's video because of this session, please finish up watching today's assigned videos in your own time. Okay. All righty. I'll see you guys on Tuesday.
Okay, bye, Professor.
Okay? Stay safe and take care.
You too.
Thank you as well.
All right, you too. All right. Stop recording.